Okay guys, I'm going to try to go over stoichiometry with you. I know some of you, it's been a long time, especially you guys seniors, it's been a long time since you've done stoichiometry. Remember, stoichiometry really is just a real fancy word meaning a mathematical relationship, kind of in a balanced equation. You're looking at how many molecules of one thing that you would have to the other. We could convert everything to molecules and start using molecule relationships, but that's going to get pretty technical, so we just say they're mole relationships. So if we look at this equation, for every one sodium silicate here, for every one of these guys, I'm going to actually need 8 hydrofluoric acids. I'm going to get 1 of this product and 2 of this product and 3 of this product. And that's really all stoichiometry is. We relate this and we use stoichiometry if I wanted to, say, if I had 8 grams of hydrofluoric acid and I wanted to know how much water was going to get produced in this reaction, that's why I use stoichiometry. So in stoichiometry, you have one of the thing from your equation and you're looking for something completely different in the equation. So we're going to begin with the examples for those of you that missed part of it in class or want to just back this lesson up and just see it again. I'm going to do the best I can. I'm here after school, just me and the board, so I don't know how to pace this thing. It's kind of awkward, and I don't like to talk or like to hear my voice. But we're going to begin with letter A. And letter A says, how many moles of hydrofluoric acid are required to dissolve in 0.5 moles of sodium silicate? So I would like you, and just as I made you do in pre-AP, I would like you to identify your given and your wanted. And the only reason that is for you to know where you're going to start the problem and where you should end the problem, because I've learned that if I don't make you do given and wanted, you'll kind of either go too far or not go far enough. So this one's the beginning, easy one. We are going to begin, our beginning information is that we are given 0.5 moles of sodium silicate, which is Na2SiO3, and you are looking for moles of hydrofluoric acid. So there's our beginning, and this is where we want to end. So we always begin, just as we begin any problem, we begin by taking our given and we're going to put it over 1. And just as we do any other problem, this is going to completely go down to the side. Now, what's making this one different than normal is mole can take us anywhere, but we've got moles of sodium silicate, and I'm actually looking for not sodium silicate, but hydrofluoric acid. And so the way you switch from one compound to a different compound is known as the mole-mole ratio. The mole that you don't want is on bottom, and the mole that you do want is on top. And it's the only time you can have different compounds on top of each other if it's mole over mole. So you're not going to ever have gram over gram or molecule over molecule, but it's mole over mole, and you can have 2 different. That's why I stress putting those labeling on there for we can see this. And I always said you're going to put 1 with the word mole until we get to stoichiometry. Now it's not necessarily going to be a 1 with the word mole. It's going to depend on our balanced equation. So now we're going to look up in our balanced equation, and we'll pick on this one first. And we're going to look for hydrofluoric acid. Up in the balanced equation in front of hydrofluoric acid is an 8. And what that means, it's going to take 8 moles of hydrofluoric acid for this reaction to go. And proportionally, for every 8 of these, there just so happens to be 1 of the sodium silicate. It's not always 1 there, but for this equation, it's always 1. And so you can see that your moles are going to cancel, and if I will multiply, you're going to find your answer here. And this particular problem only has 2 significant digits, so it's going to be just 4.0, and it'll be moles of HF. Now, a lot of you could have seen that anyway. Maybe you could see the 1:8 ratio in your head, and you say, I wouldn't necessarily need to do a tic-tac. The reason the tic-tac is helpful is when they have like 9:13 ratios. Well, your brain doesn't handle that as well, so the tic-tac helps you to be able to do that math if you're not very good at seeing ratios. So our answer here would have been 4.0 moles of HF, and I know I stopped my tic-tac because I've gotten to where I want. So there's a very, what we call a baby mole problem, very easy one to do. Alright, so I'm just going to erase where we can keep that balanced equation sitting up there. And then we're going to go on to B. Letter B says, How many grams? So we're going to identify our given and our wanted. And we are looking for grams. How many grams of sodium fluoride? Sodium fluoride's NaF. When you react 0.300, we've got moles of hydrofluoric acid, HF. So this is where my given information, that's the number, and then your wanted is what you're looking for. So you're going to begin with 0.300 moles of HF over 1. And what's going to come down, you're going to always bring this down. Uh-oh, I already made an error. Sorry. Let me go back up. This should not say HF. Nope, it should. Unfortunately, when it's live, it's just going to live. I'm not going to stop and correct it. That is correct. Now we're going to go moles of HF down. Now, I'm not wanting HF in the end. I'm wanting sodium fluoride, so I'm going to have to switch. And the way we switch is known as the mole-mole ratio. And you can't switch to the mole-mole ratio until you have the mole, which I already have the mole. So I've got Na. F is going to be going to the top. I'm going to now look in front of NaF is a 2, so a 2 will go here, and in front of HF will be an 8, and so I'll be putting an 8 there. Am I going to stop? Here's my question, am I going to stop? How are you going to know whether or not you're going to stop? Well, you're going to look here, and it's got grams, and I'm not at grams, so that means the tic-tac has to keep going. So coming down now will be the word mole. Going to the top will be grams. Now, this is called the molar mass. How many grams are in 1 mole? So there should be a 1 here. I'm going to go to the periodic table and find out 1 sodium and 1 fluorine. If I add those together, it does make 42. Notice, this is going to be always a 1. The only time it's not a 1 is when it is the mole over mole. Then I'm using the coefficient. So if it doesn't say mole over mole, you're going to be using 1 with the word mole. Okay, so I'm going to stop because this is going to cancel with this, and look what I've got here in this corner. I've got grams of sodium fluoride. Notice in stoichiometry we do not use Avogadro's constant, 6.02 times 10 to the 23rd. And the reason is I didn't ask for how many atoms were going to be formed or how many molecules are going to be formed or how many formula units are going to be formed. I'm asking for grams. So in stoichiometry, we do not really use 6.02 times 10 to the 23rd. I guess you could, but I've never seen a problem really where you would be doing that. So this is going to be answer 4. It has 3 significant digits, 3.15. If you multiply across the top and then divide by your bottom, you're going to get that you're going to end up making 3.15 grams of sodium fluoride. Alright, our last type of problem is known as, I call it the mass problem. It is the most common type, and the reason it's the most common type is because it's more realistic of what you were going to be doing. If you were working in a factory or something and you needed to make 10 grams of a substance, you would want to know how many grams you would need to start with. So the reason I call it mass is because you start with 1 mass and you're looking for a different mass. It says how many grams of sodium silicate can be dissolved when you have 0.300, this time not moles, but grams of hydrofluoric acid. And I am looking for grams of sodium silicate. So this is my given and this is my wanted. So you're going to begin and start with your given. And we're going to put that over 1. Coming down is going to be your grams. Now you're going to ask yourself, can I switch yet? And your answer should be no. You can't switch until you're at the mole. I'm not at the mole, I'm at grams, so you can't switch yet. So you got to stick with mole, and we still got to have HF. Notice this is not mole over mole, so it's not going to be different substances. That's why we got those labels going on. And what am I going to put with this word mole? I'm going to put a 1. It always is a 1 with grams because we're dividing by the molar mass. So I'm going to find this off the periodic table. This equals 20.01. This is going to cancel. If I stop right there, I'm just going to have moles of HF. I'm not looking for moles of HF. I'm looking for grams of sodium silicate. So now I've got to switch it. What's going to come down? Well, mole of HF is coming down. I got to switch it. So moles of Na2SiO3 will go to the top. Now I've got mole over mole. I'm going to now look at my coefficients. In front of this is a 1. In front of the HF so happens to be an 8. We've been dealing with that a few minutes. This is going to cancel. If I stop right now, I'm going to have the moles of sodium silicate. Am I going to stop? No, because you're looking for grams of sodium silicate. So I'm going to keep going. Let's scoot this over a little bit. And bring down will come moles of Na2SiO3. Sodium silicate, looking for grams of Na2SiO3. With this mole, because that's a gram, it's always going to be a 1. And I'm going to pull off the periodic table. I'm going to add up 2 sodiums, 1 silicon, and 3 oxygens, and that does add up to 122.1. This will cancel. And I'm just going to multiply, and then I'm going to multiply and then divide. You guys that like to do it in one step in your calculator, if you like multiply and then divide, when you guys do this, make sure that you put a parentheses around that in your calculator. They need to be together inside a set of parentheses or you'll get the wrong answer. And you should be coming out with 0.229 grams of sodium silicate. And that's pretty much stoichiometry. I think first period I know that you got to limited reagents, and third period did not get to limited reagents, so I'm going to do limited reagents in another video section. Okay, so I'm going to stop with just stoichiometry, upload the stoichiometry, and then tomorrow I will try to do the limited reagents. So first period, if you don't get this, do know that you your homework has been shortened, and also we're going to not have a quiz next time because we're going to make sure you understand this. So we're going to stop that stoichiometry. Hopefully this helped a little. Again, this is the mass problem. If you'll just look where you're going, unless your tic-tac leads you, it'll lead you exactly where you need to go. And I think most of you got really good at stoichiometry whenever you had pre-AP. So that's all for today.